Hey everybody, welcome back to our second video for notes number 18. Now that we've seen in general what the exponent rules are, our next step is to start applying them. So, example 1. Notice I have the same base of 4. The first has an exponent of 2, the second one has an exponent of 1, but notice that they do have the same base. That means I can write the base one time and add the exponents. That's what we would call exponent form. However, if we were asked, we could also actually multiply these together. 4 squared is 16 times 4 again would be 64. So these two things mean the same. We can follow the same rules. Even when I've got negatives, remember that if that negative is hugged, it is part of the base. So these have the same base, meaning I can write that base one time. And then combine their exponents by adding. 2 plus 3, negative 2 to the 5th. That is what we call the exponent form. If I was asked, I could actually go ahead and evaluate that. To evaluate it, that just means go ahead and multiply it all together since everything is numbers. So I have negative 2 times negative 2 times negative 2 times negative 2 times negative 2. There's 5 of them. When we did this when we originally talked about exponents, we just kind of grouped them up and multiplied. So these two, negative times negative is a positive 4. These two, negative times negative is a positive 4. And I have one more negative 2 hanging around. Then I multiply again. 4 times 4 is 16. Times that last negative 2 would be negative 32. So just be careful depending on how your homework asks you to write. This is the exponent form. This is once we've actually evaluated it. These rules apply no matter what your base is. Now please note, I can only evaluate like that when everything I have is a number. If your base is a letter like it is on 3, my base is C, my base is C, I have the same base. So I can write that base one time. Here, I'll just write it as the regular letter C. Because these were listed out separately, that rule tells me I should add my exponents together. 6 to the 8th. I'm sorry, C to the 8th. Whew. C to the 8th. And this works no matter how many of your bases you have. In the next one, all of them have the same Y as my base. Because I'm multiplying these together, and because they're all listed out separately, I can take my exponents and add them all together. 3 plus 1 plus 5 is Y to the 9th. Be sure when you do this that you have that 9 up there in the exponent spot. It is different when you put the 9 in the exponent spot versus when you put it side by side. So just be careful with that. Now, there will be plenty of times that my bases end up changing up a little bit. Looking at number 5, I have a 3 times an x squared times a negative 5 times a x to the 6th. So anywhere there was a multiplication, I went ahead and just wrote the multiplication sign. If I separate it out like this, then I can combine the things that look alike. I can take my 3 and my negative 5 and multiply them together to get negative 15. But I can also then take my x's, x squared times x to the 6th, and simplify them. Because they have the same base, I write that base one time and add their exponents. 2 plus 6 is 8, giving me a final answer of negative 15x to the 8th. Don't lose sight of our goal here. Our goal is just to perform the operations, to simplify how it looks by combining those similar cases, those similar bases, until I can't combine anything else. Negative 15 and x to the 8th are two separate bases. They cannot combine. Let's try another one. Starting off with my numbers, I have a 3, a 4, and a 2 that can all get multiplied together. 3 times 4 is 12. 12 times 2 is 24. That takes care of my numbers. Now, I can only combine the ones that have the same base. So next, I would have my a's, a cubed, and another a that all have the same base. Those can be simplified by writing the base one time and adding the exponents. If there is not an exponent written in, put it as a 1 and add it up. So 1 plus 3 plus 1 is a to the 5th. That takes care of my a's. Next up, I have b's. So I have a b squared, a b, and a b. So b squared times b times b, I can write that single base one time. Make sure you go ahead and put your exponents in there so you don't leave them out. I end up with 1, 2, 3, 4 of those bases. So the rule says I take 2 plus 1 plus 1, b to the 4th in all. Whew, still not done, but we're getting closer. Now I can put my c's together. So I have a single c, a c squared, and another c. Write the base one time and add your exponents. 1 plus 2 plus 1. Write your c base one time, and when I add my exponents together, I get 4. All of these together now simplify my original result into 24, a to the 5th, b to the 4th, c to the 4th. So anytime I have my bases listed separately, being multiplied, I add my exponents. That shifts gears a little bit if I'm dividing instead of multiplying. So looking at number 7, I have the same physical base. Base of 3, base of 3. The exponent rule says I can write that base of 3 one time. And because I'm dividing this time, I'm going to subtract my exponents. 3 as my base, 7 minus 5 gives me 2 as an exponent, leaving my final result to be 9. Please notice how using that exponent rule made my life a whole lot simpler than trying to find 3 times 3 times 3 times 3 times 3, so on and so on and so on, and then having to divide. Simplifying these exponents first before you move into that multiplication division can really simplify our life. And just like we've had before, we can have a variety of bases involved. Just follow the bases. On top, I have an x to the 8th, On bottom, I have an x to the 4th. So what I can do is I can focus just on those x's, writing it one time, and then I take their exponents and subtract top minus bottom, leaving me x. 8 minus 4 is 4. Then I can look at my y's. Because those are the same base, I can write that y one time. Top exponent is 3. Divide tells me to subtract the 1 that's on bottom, leaving me y squared left over. Together, there is my simplified result. You've seen several of these, kind of the general process now. Feel free to pause and try number 9. All right, assuming you've paused if you wanted to, now let's look at number 9 together. Remember to follow the bases that look alike. Right, we've talked about like terms before. 10 and 2 are alike as my base because they're both just numbers. So I can take 10 and divide it by 2, giving me 5. Then I look at my m's because they have the same base. I write that same base one time and then deal with my exponents. Because this is division, 5 minus 3. Subtract those exponents, top minus bottom, leaves me m squared. And last but not least, I've got my n's. Because those have the same base, I can write that in one time and subtract 10 minus 4 on those exponents, leaving me m in to the 6th. So the simplified version of this big thing would be 5 times m squared times n to the 6th. Good. So we've looked at the power rule, we've looked at the quotient rule. That's when we've added and subtracted our exponents. Now we're going to look at what's called the power rule. I want you to stop and notice the difference. Everything we've been doing up to this point, the exponent each had its own base. And I wrote that base one time, added or subtracted the exponents. Now, things look a little different because I have what we call a shared. It's done so good, now it's jumping on me again. I have what's called a shared base. When you share the base, you still write it one time. But because I'm sharing that base, I need to multiply the exponents together. 2 times 5 gives me b to the 10th. This is because of what we saw in our first video where we kind of explored. That's because this physically means I have b squared, b squared, b squared, b squared, and b squared. I have 5 of them. 2 plus 2 plus 2 plus 2 plus 2 is 10. But rather than having to write it all out like that, I'm able to shortcut it by multiplying those, what I'm going to call a double exponent, together. Let's try another one of those. Notice I have a shared base. So I write that base one time, just like I already had it one time. And then I multiply together the double exponent. 3 times 6, giving me w to the 18th. And that's true even when I've got negatives inside. This next one, my -3 is the base. That negative is hugged. and it's only written one time. These others are a double exponent. So I multiply 2 times 2 is -3 to the 4th. Again, this is the exponent form. If we are asked to evaluate it, we could take our -3 to the 4th and multiply it out. These first two multiplied together give me a +9. Second two multiplied together give me another +9. Because I'm multiplying negative times negative turns positive. 9 times 9 is 81. Good. Well, we are rocking right along. We have 2 more that are playing with that. Actually, no, that's not true. Let me stop right here. In this video, we have added, subtracted our exponents, and now we have seen what it looks like to have to multiply them. In our next video, we're going to learn how to distribute our exponents and how to combine all of these rules. Y'all, this is only the first lesson of exponents. We will continue to practice it for several lessons to go.